Hi everyone, welcome back to my channel Criminology and Forensic Science. In today's UGC NET Forensic Science series, we are going to study fingerprint principles. Imagine this for a moment. A burglary has taken place in a house late at night. The thief was careful. He wore dark clothes, avoided CCTV cameras, and left no obvious evidence behind. The police reached the crime scene and searched every corner, but there was no weapon, no eyewitness, and no DNA. It almost seemed like the criminal had vanished without leaving a trace. Then a forensic expert noticed something on a glass window. Under normal light, nothing was visible, but after carefully dusting the surface with fingerprint powder, a beautiful fingerprint slowly appeared. It looked like an ordinary pattern of ridges and furrows, yet hidden with those tiny ridges was enough information to identify one specific person among billions of people in the world. Isn't that amazing? Think about it. A mark so small that we often leave it without even noticing can reveal a person's identity with incredible accuracy. This is why fingerprints have been called nature's personal signature. They are silent witnesses that accompany us everywhere we go, whether we hold a pen, unlock our phone, open a door, or pick up a coffee. Our fingerprints are constantly interacting with the world around us. But have you ever wondered why forensic scientists trust fingerprints so much? Why can a court of law accept fingerprint evidence? How can experts confidently say that a fingerprint found at a crime scene belongs to a particular individual? The answer lies in a simple yet powerful scientific principles that have been tested, studied, and accepted for more than a century. Today's lecture is all about these principles, that is, the fingerprint principles. If you understand these principles clearly, not only will many UGC NET become easy to answer, but also you will understand the very foundation of fingerprint identification. Every forensic investigation involving fingerprints is based on these principles. So keep your notebook ready, stay with me till the end, because today's lecture will build the foundation for all our upcoming fingerprint topics. So let's begin. Before discussing the principles, we must first understand what a fingerprint actually is. Look carefully at the tips of your fingers. You will notice tiny rays running in different directions. These raised lines are called friction ridges, and the spaces between them are called furrows. These ridges are not decorative patterns created by nature. They serve very important biological functions. They improve our grip on objects, reduce slipping, and increase our sense of touch. Imagine trying to hold a smooth glass bottle with perfectly flat skin. It would slip much more easily. The friction ridges create additional friction, allowing us to grasp objects securely. These ridges are found not only on our fingers but also on the palms of our hands, the soles of our feet, and our toes. Together they are known as friction ridge skin. Now, when these friction ridges come into contact with the surface, they often leave an impression. This happens because the skin naturally secretes tiny amounts of sweat and oils. Even if our hands appear dry, sweat glands continuously produce moisture. When we touch a clean surface, a thin invisible layer of sweat and oil is transferred, carrying the unique pattern of our friction ridges. This impression is called a fingerprint. Sometimes fingerprints are clearly visible, such as when someone touches a surface with blood, ink, paint, or dirt. At other times, they remain invisible and must be developed using forensic techniques such as fingerprint powder, chemical reagents, or alternate light sources. We will study these techniques in detail in upcoming lectures. For now, remember the simple definition. A fingerprint is the impression or reproduction of the friction-rich skin present on the fingers. Now let us ask a very important question. Among all the evidence available at a crime scene, DNA, footprints, bloodstains, fibers, hair, tool marks, why do forensic experts still give so much importance to fingerprints? The answer lies in their unique advantages. Fingerprints are highly individualistic. The chances of two people having exactly the same fingerprint are considered practically impossible. Even identical twins who share almost identical DNA have different fingerprints because the tiny events that shape fingerprint ridges in the womb differ from one fetus to another. Fingerprints are permanent. Once they develop before birth, they remain unchanged throughout life unless the deeper layer of the skin is permanently damaged. Fingerprints are easy to leave behind. Every time we touch a surface, we may unknowingly leave fingerprints. Criminals often forget this fact. They may hide weapons, destroy documents, or remove CCTV recordings, but a single unnoticed fingerprint can reveal their identity. Fingerprints are easy to compare using scientific methods. Modern computer systems like AFIS can compare thousands or even millions of fingerprint records within a short period, making investigations much faster and more accurate. This is why fingerprint evidence has become one of the most trusted forms of physical evidence in forensic science. Now that we understand what fingerprints are and why they are important, let us discuss the central topic of today's lecture. What exactly do we mean by fingerprint principles? Fingerprint principles are the fundamental scientific rules on which the entire science of fingerprint identification is based. These principles explain why fingerprints can be used to identify individuals accurately and reliably. Without these principles, fingerprint evidence would have no scientific foundation. Every fingerprint expert, every forensic laboratory, and every automated fingerprint system works according to these principles. Although many books discuss several characteristics of fingerprints, forensic science traditionally recognizes three fundamental principles. The principle of individuality. No two individuals have identical fingerprints. The principles of permanence. Fingerprints remain unchanged throughout life. The principle of classification. Fingerprints can be grouped into systematic patterns such as arches, loops, and whorls. These principles were not created overnight. They are the result of years of careful observation and scientific research. Long before fingerprints were used in criminal investigations, scholars noticed that no two fingerprints appeared exactly alike. In the 19th century, pioneers like Sir William Herschel, Dr. Henry Faulds, Sir Francis Galton, and later Sir Edward Henry conducted detailed studies of fingerprint. They collected thousands of fingerprint impressions and compared them carefully. Despite examining enormous numbers of prints, they never found two identical fingerprints belonging to different individuals. Sir Francis Galton in particular scientifically demonstrated the uniqueness and permanence of fingerprints through extensive research. His work laid the scientific foundation for fingerprint identification and influenced forensic science across the world. Later, Sir Edward Henry developed the Henry classification system, making it possible to organize and search fingerprint records efficiently. We will discuss this system in a later lecture. The important point to remember in that these principles are not assumptions or guesses. They are based on scientific observation, research, and practical experience accumulated over many decades. Now we come to the most important fingerprint principle, that is individuality. This principle states no two individuals have identical fingerprints, not even identical twins. This is the cornerstone of fingerprint science. When forensic experts compare fingerprints, they rely on this principle. If two fingerprints match in all significant details, they conclude that they came from the same person because no one else possesses that exact arrangement of rich characteristics. But why is this true? To answer that, we need to understand how fingerprints develop. Fingerprints development begins before a baby is born. Around the 10th week of fetal development, tiny ridge formations start appearing on the fingers. Over the next several weeks, these ridges continue to grow and take shape. Although genetics influences the general appearances of the ridges, it does not completely determine their final arrangement. During fetal development, many tiny environmental factors inside the womb play a role. These include slight differences in pressure within the uterus, the position and movement of the fetus, blood circulation, the amount of amniotic fluid, and the countless random developmental events. These factors interact in unique ways for every developing fetus. As a result, the friction ridges form a pattern that has never existed before and will never be repeated again. This is why fingerprints are considered unique to each individual. Even identical twins who develop from the same fertilized egg and share nearly identical genetic material experience slightly different conditions inside the womb. These subtle differences are enough to produce different rich characteristics, making their fingerprints unique. Let me explain this further. Just think that 100 students are asked to draw a tree. They all receive the same paper, the same pencil, and the same instruction. Even then, every drawing will be slightly different. One student may draw thicker branches, another may draw smaller leaves, while someone else may place the roots differently. Now imagine nature creating fingerprints instead of drawings. Although the biological process is similar for every human being, the tiny details produced during development differ from one person to another. These tiny differences make every fingerprint unique. That is the beauty of fingerprint individuality. For example, a mobile phone has been stolen from a university library. The police recover the phone from a nearby park. The surface is carefully examined and a latent fingerprint is developed using fingerprint powder. The fingerprint is photographed and compared with the fingerprints of several suspects. One suspect has a loop pattern, another also has a loop pattern, and a third also has a loop pattern. Does this mean all three fingerprints are the same? Of course not. The fingerprint examiner does not stop at the overall pattern. Instead, they compare the tiny rich characteristics such as ridge endings, bifurcations, dots, islands, and enclosures. The exact arrangement of these features is unique for each individual. When the fingerprint from the phone matches the unique ridge characteristic of one suspect and not the others, the examiner concludes that the fingerprint belongs to that particular individual. This demonstrates how the principle of individuality works in real forensic investigation. Many students believe that if two people have loop fingerprints, their fingerprint must be identical. This is incorrect. The pattern may be the same, but the minute ridge characteristics, their positions, directions, and relationships are different. That is why forensic experts rely on minutiae rather than pattern type alone for personal identification. For the examination, always remember this distinction. Patterns classify fingerprints, rich characteristics identify individual. This single concept can help you answer several objective and descriptive questions. Now that we have understood the principle of individuality, let us move to the second fundamental principle of fingerprint science, known as the principle of permanence. This principle is equally important because it answers one of the most common questions people ask about fingerprints. Do our fingerprints change as we grow older? Think about your own life for a moment. When you were born, your fingers were very tiny. Today, your hands are much larger. As you continue to age, your skin will develop wrinkles, your hair may turn grey, and many parts of your body will undergo visible changes. Yet, despite all these natural changes, forensic scientists can still identify you using your fingerprints. How is that possible? The answer lies in one remarkable fact of human biology. Although the size of your fingers increases as your body grows, the arrangement of your friction ridges remains exactly the same throughout life. This scientific fact forms the basis of the principle of permanence. The principle states once fingerprints are fully developed before birth, their rich characteristics remains unchanged throughout an individual's lifetime unless the deeper layer of the skin is permanently destroyed. This is one of the reasons why fingerprints have been accepted as reliable evidence in courts around the world for well over a century. But to truly appreciate this principle, we first need to understand how principles develop before birth. Many people believe fingerprints develop after birth as we begin touching objects. That is a common misconception. In reality, fingerprints formation begins long before a baby is born, around the 10th week of fetal development. Tiny swellings known as volar pads are present on the fingerprints, palms, and soles. These pads play a major role in determining the overall fingerprint pattern. As the fetus continues to grow, these pads gradually regress and friction ridges begin to appear over them. Between approximately the 10th and 16th weeks of gestation, these ridges continue to develop and organize into arches, loops, or whorls. By around the 24th week of pregnancy, the friction-rich skin is fully formed. From this point onwards, the overall arrangement of ridges does not change. The baby carries the same fingerprint pattern from the womb into childhood, adulthood, and old age. This is why a fingerprint taken from a child can still be matched many years later when that individual becomes an adult. Now comes the next important question. Why don't fingerprints disappear when a skin constantly sheds old cells and produces new ones? The answer lies in the structure of the skin. Our skin has two major layers. The outer layer is called the epidermis, while the deeper layer is known as the dermis. Between these two layers lies a specialized structure called the dermal papillae. It is this deeper structure that determines the arrangement of friction ridges. The cells of the epidermis are continuously replaced throughout life. Every few weeks, old skin cells are shed and new cells are formed. However, these new epidermal cells grow by following the same blueprint provided by the dermal papillae beneath them. You can think of it like constructing a building using the same architectural plan. Even if individual bricks are replaced over time, the overall structure remains exactly the same because the blueprint never changes. Similarly, although our skin cells are constantly renewed, the rich pattern remains unchanged because the underlying dermal structure remains intact. This is the scientific reason why fingerprints are considered permanent. Now, some of them become confused when they hear that fingerprints remain unchanged. They ask, if a baby's finger is so small and an adult's finger is much larger, how can the fingerprints be the same? This is an excellent question. Imagine drawing a design on a balloon. Before inflating the balloon, the design is small. As you inflate it, the design becomes larger, but its shape and arrangement remain the same. The same principles applies to the fingerprints as well. As a child grows, the fingers increase in size. The ridges become farther apart because the skin stretches, but their relative arrangement does not change. Therefore, fingerprint experts can compare fingerprints taken decades apart and still establish identity. Now let us consider another practical situation. Suppose you accidentally cut your finger while chopping vegetables. Will your fingerprint disappear forever? The answer is no, provided the injury affects only the superficial layers of the skin. Minor cuts, abrasions, scratches, burns, or peeling skin usually damage only the epidermis. Since the dermal papillae remain intact, the skin heals by reproducing the same rich pattern that existed before the injury. After healing, the original fingerprint reappears. Many of us have experienced small cuts on our fingers during childhood, yet those injuries do not permanently change our fingerprints. This remarkable ability to regenerate the original rich pattern further supports the principle of permanence. Although fingerprints are permanent, there is one important exception. If an injury destroys the dermal papillae, the original ridge pattern cannot regenerate completely. Such deep injuries may result from severe burns, deep cuts, industrial accidents, or certain surgical procedure. Instead of the original friction ridges, the injured area heals by forming scar tissue. This scar becomes a permanent feature of the fingerprint. Interestingly, even these scars became identifying features because their shape, location, and appearance are unique to the individual. Thus, while the original rich pattern may be interrupted in that area, the fingerprint can still serve as valuable forensic evidence. This is one of the most fascinating questions in forensic science and is often shown dramatically in movies. Some films portray criminals burning their fingertips with acid or cutting away their skin to avoid identification. But does this really work? In most cases, no. If only the outer skin is damaged, the friction ridges regenerate exactly as before. History provides several examples where criminals attempted to destroy their fingerprints by burning, cutting, or abrading their fingertips. However, after healing, the ridge patterns either reappeared or left distinctive scars that made identification even easier. Even if part of the fingerprint is permanently scarred, the remaining rich characteristics, along with the scar pattern itself, often provide enough information for identification. Therefore, intentionally damaging fingerprints is rarely an effective method of avoiding forensic detection. Today, fingerprints are not only used in criminal investigation. Many of you unlock your smartphones using fingerprint sensors. Officers use fingerprint attendance system. Banks and government agencies rely on biometric authentication. Airports, immigration checkpoints, and national identity system also use fingerprints for secure identification. Why do all these systems depend on fingerprints? Because engineers and scientists know that fingerprint patterns remain stable throughout life. A fingerprint enrolled today can still authenticate the same individual many years later. This reliability makes fingerprint recognition one of the most trusted biometric technologies in the world. Here is an easy way to remember the principle of permanence. Imagine planting a mango tree. Every year the tree grows taller. Now leaves appear, old leaves falls, branches become thicker, and fruits come and go. The tree grows and changes in size, but it remains the same tree because its roots stay the same. Similarly, your fingers grow larger, your skin continuously renews itself, and your body ages, but the underlying rich blueprint remains unchanged. Whenever you think of fingerprint permanence, remember this image of a growing tree with the same roots. Students often confuse permanence with individuality. Remember the difference carefully. Individuality asks the question, why is every fingerprint different? Permanence answers the question, why does the same fingerprint remain unchanged throughout life? If you clearly understand this distinction, many conceptual questions become very easy to answer. As we move ahead, we have now understood that fingerprints are not only unique but also remarkably stable throughout an individual's lifetime. However, for fingerprint science to be practical in forensic investigation, experts need an organized method to arrange, classify, and retrieve millions of fingerprint records efficiently. This brings us to the third and final fundamental principle of fingerprint science, the principle of classification, which we will now explore in detail. At first glance, this principle may seem simpler than the previous two. However, it solved one of the biggest practical problems in the history of forensic science. Imagine that you are a fingerprint examiner working in a forensic laboratory more than 100 years ago. One day, the police bring you a fingerprint recovered from a crime scene and ask you to identify the person who left it behind. But there is a challenge. Your laboratory has fingerprint records of more than 5 lakh people. There are no computers, no digital databases, and no automated search systems. Every fingerprint is stored on paper cards inside large filing cabinets. Now think for a moment, if these fingerprint cards are kept randomly, how long would it take to find the correct record? Days, weeks, perhaps even months. Searching every single fingerprint manually would be almost impossible. This is exactly the problem forensic scientists faced during the early years of fingerprint identification. They needed a scientific method to organize fingerprint records in such a way that searching became faster and easier. This need gave rise to the principle of classification. The principle of classification states fingerprints can be systematically grouped into different pattern types based on the general arrangement of friction ridges. Notice something very important here. Classification does not identify a person. Instead, it helps us organize and locate fingerprint records efficiently. Think of a library. Thousands of books are arranged according to subjects. Science books are placed together. History are placed together. Likewise, literature are placed in another section. This arrangement does not tell us which book belongs to a particular author, but it makes finding a book much easier. Fingerprint classification works exactly in the same way. Instead of searching millions of fingerprints individually, experts first divide them into groups based on their overall patterns. Only after narrowing down the search do they compare the detailed ridge characteristics. According to the principle of classification, fingerprints are primarily grouped into three major patterns. These are arch, loop, whorl. Every fingerprint found in the world belongs to one of these major groups or one of these subtypes. These patterns are based on the overall flow of ridge patterns, not on individual ridge characteristics. We will study each pattern in great detail in our next lecture. For now, let us understand their basic appearance. The arch is the simplest fingerprint pattern. In this pattern, the friction ridges enter from one side of the finger, rise gently in the center like a small hill, and exit from the opposite side. There is no backward turning of ridges. Generally, arches do not possess a true delta, making them easy to distinguish from loops and whorls. Arch patterns are the least common fingerprint pattern found in humans. Only about 5% of the world's population has arch fingerprints. You can remember an arch by imagining a small bridge or a rainbow gently curving across the sky. The loop is the most common fingerprint pattern. Here, the friction ridges enter from one side of a finger, curve around and leave from the same side from which they entered. Loops contain one delta and one core. Approximately 60 to 65% of all fingerprints belong to the loop category, making it the most frequently encountered pattern in forensic investigations. Loops are further divided into ulnar loop, radial loop. These subtypes depend on the direction in which the loop opens. The third major pattern is the whorl. Whorls are easily recognized because their ridges form circular, spiral, or concentric patterns. Unlike loops, whorls generally possess two deltas. Around 30 to 35% of fingerprints belong to this category. Whorls appear visually striking and are among the easiest patterns to recognize. Like loops, whorls also have several subtypes including plain whorl, central pocket loop, double loop, and accidental whorl, which we will study separately. Now, let us understand why fingerprint classification is so important. Just think a national fingerprint database containing 1 crore fingerprint records. Suppose investigators recover a fingerprint from a crime scene. Without classification, they would have to compare the fingerprint with every single record in the database. That would consume enormous amounts of time and computational resources. Instead, the fingerprint is first classified. If it is identified as loop, investigators immediately exclude all arches and world records. This simple step drastically reduces the number of possible matches. Only after narrowing the search do experts compare each characteristic. Thus, the classification acts as the first filter in the fingerprint identification. The importance of classification became even more greater with the development of Henry classification system by Sir Edward Henry in the late 19th century. Before this system, organizing fingerprint records was extremely difficult. Henry's method provided a logical way to arrange fingerprint cards according to mathematical principles and pattern types. Police departments around the world soon adopted this system because it allowed investigators to retrieve fingerprint records quickly and efficiently. Even though modern forensic laboratories now use computerized databases such as AFIS, the basic concept of fingerprint classification remains extremely important. Computers also organize and search fingerprint records based on similar principles before performing detailed comparison. Today, fingerprint identification has become much faster because of automated fingerprint identification system. Instead of manually searching cabinets filled with fingerprint cards, investigators simply scan the fingerprint into the computer. The software first analyzes the overall fingerprint pattern. It then studies ridge flow, core, delta, and ridge characteristics. Finally, it searches millions of records within minutes and generates a list of possible matches. The fingerprint examiner then performs the final comparison using scientific methods. Thus, although computers perform the search, the principle of classification still forms the backbone of the entire process. Suppose investigators recover a latent fingerprint from a burglary scene. The print is first examined carefully. The examiner notices that the ridges enter from one side, curve around, and leave from the other side. This indicates that the fingerprint belongs to the loop category. Immediately, all fingerprints classified as arches and whorls can be excluded from the initial search. The AFIS system now compares the latent fingerprint only with loop fingerprints stored in the databases. Within minutes, the software produces several possible matches. The examiner then compares the ridge endings, bifurcations, dots, and other minutiae to determine the true source of fingerprint. This demonstrates how classification saves both time and effort during forensic investigation. Students often confuse the three principles. Here is a very simple way to remember them. Imagine meeting a new student in your classroom. First you ask, "Who are you?" The answer comes from individuality because every person is unique. Next you ask, "Will I recognize you after 10 years? The answer comes from permanence because fingerprints remain unchanged. Finally, you ask, "Which classroom should I place you in?" The answer comes from classification because fingerprints are organized into groups. So remember, individuality identifies, permanence preserves, classification organizes. If you remember these three words, you will never confuse the principles in the examination. For objective examination, students should remember these important facts. Individual means no two individuals have identical fingerprints. Permanence means fingerprint ridge arrangements remain unchanged throughout life unless the dermal papillae are permanently damaged. Classification means fingerprints are systematically grouped based on their overall ridge patterns. The three major fingerprint patterns are arch, loop, and whorl. Patterns are used for classification, whereas ridge characteristics or minutiae are used for personal identification. The Henry classification system played a historic role in organizing fingerprint records. Modern AFIS still relies on the concept of classification before performing detailed comparisons. These are among the most frequently tested concepts in UGC NET university examinations and competitive forensic science exam. So friends, with this we have completed one of the most important foundation topics in fingerprint science, the three fundamental principles of fingerprints. We began by understanding the principle of individuality, which tells us that no two individuals in the world, not even identical twins, have identical fingerprints. We learned that every fingerprint is a unique biological signature created during fetal development through a combination of genetic and developmental factors. Next, we explored the principle of permanence, where we discovered that fingerprints begin forming before birth and remain unchanged throughout life because dermal papillae preserve the rich blueprint. We also understood why minor cuts heal with the original rich pattern, while only deep injuries affecting the dermal layer can cause permanent changes. Finally, we discussed the principle of classification, which enables forensic scientists to organize millions of fingerprint records into systematic groups such as arches, loops, and whorls. We saw how this principle transformed fingerprint identification from an impossible manual task into an efficient scientific process, and how modern AFIS technology continues to rely on the same concept. In our next lecture, we will move together for another exciting topic, fingerprint patterns. We will study about arches, loops, and whorls in detail, understand their subtypes, learn how to identify them accurately, and explore their significance in fingerprint classification and forensic investigations. This topic is especially important because questions based on fingerprint patterns are frequently asked in UGC NET and other competitive examinations. If you found this lecture helpful, please like the video, share it with your friends who are preparing for UGC NET Forensic Science or any other examination, and subscribe to the Criminology and Forensic Science channel if you haven't already. Your support motivates me to create more detailed, student-friendly lectures to help you achieve your goals. Until our next class, keep revising, stay curious, and always remember one beautiful truth about forensic science. Every fingerprint is silent, but when examined scientifically, it speaks the truth. Thank you for watching, and I'll see you in the next lecture.